It's going to seem kind of dumb, but I just wanted to review this. This is from the Berkeley uh, education site, Berkeley University. Alright, you have your mineral on the left-hand side, and you have your composition. Your composition is separated into the elements and molecules. And the reason why I want to go over this is because all these combinations of elements to make the molecules, which are called minerals, are direct evidence for chemical combination reactions. When a star is very young, all these elements are separated from each other, which means if we find them together, they had to combine with each other at one point because of some process. Plate tectonics doesn't explain this, and neither does the entirety of geology, but I believe stellar metamorphosis explains it because it states quite clearly that elements combine to make molecules as the star evolves. I even wrote it down here, look. Stellar metamorphosis is a physical theory of star evolution, not mathematical. It explains what happens as a star cools and combines its elements into molecular compounds. This means when the elements are completely ionized and in their plasmatic state, that's what young stars are comprised of, and as the star cools and dies, it forms molecular compounds. Okay? Which means molecular compounds are direct evidence for chemical synthesis reactions, which in this case are probably mostly exothermic. And back to the actual minerals, which are structured material. Calcium, I think that's manganese or magnesium, I'm not too sure which, I can't remember. Zinc, arsenic, O is oxygen obviously, H, hydrogen, Ni, nickel, titanium, niobium, iron, thorium, cesium. Okay. These are molecular compounds that exist all over the earth, okay, in the form of minerals. A whole bunch of them, look. Andalusite, aluminum 2, silicon, and oxygen, 5 of those. Look at all these. Lead, sulfur, copper, sulfur. Enormous amount of molecular compounds from individual elements. Potassium, manganese. Oh, that's manganese, I think. Okay. There's things. I think that's, yeah, arsenic, yeah. Duh. And this is just the A's. Okay? Look at all these. There's B's. Look at all these different chemical combinations that we're dealing with here. Bismuth, Bi. Look at all this. This is incredible. I think I'm going to go ahead and link this page to people because I want them to understand it. Iridium, I think that's platinum. And you have rhodium, I think that's rhodium. Chromium. Look at all these different combinations of naturally occurring chemical compounds, which are called minerals. And I think it's kind of funny because people like Electric Universe and establishment science, they want you to believe that, you know, these minerals are not really all that important. I mean, you can test them out to see what elements they're made out of, but after that, they just throw their hands up in the air and they say, oh, we don't understand how they formed. Well, they formed as a direct result of the star cooling and combining elements into molecules in very large scales. Some even have water in them, H2O. Earl Shannonite. Probably named after Earl Shannon, whoever that was. But look at all of this. This is incredible. There's no way the theory of plate tectonics or even the rock cycle can explain all of these chemical combinations. There's no way. No way. How do you explain to me how iron and titanium combine with oxygen inside of the rock cycle? Come on, man. That's ridiculous. What actually happened is that the iron, titanium, and oxygen were free radicals, and they combined with each other in large crystalline chains, and then became rock-like when the star cooled and died. Nickel and tellurium, I think that is, I'm not too sure. But people want to say, well, how does life form? I'm not too sure, you know. Maybe they should look at the minerals that are on the ground and understand that Mother Nature makes chemical combinations freely. Now, given all these chemical combinations, she's bound to hit gold somewhere by taking carbon and just combining it in different combinations. I mean, look how much effort Mother Nature put into making a wide variety of chemical combinations. She gave it her best shot with all these minerals. Look, copper, oxygen, carbon. She probably tried with that one, didn't work. Tried another one, didn't work. And there's one in here that I wanted to point out to you guys. See if I can find it. Oh yeah, metaborite, HBO2. Oxygen, boron, and hydrogen, boron, and oxygen. HBO. They even got a mineral named HBO. Isn't that cool? But look at all this. This is incredible. Mercury and carbon. Look. Should probably try to make life out of mercury and carbon right there. I mean, seriously, look at all this. This is incredible. Let's check out the Z's. I want to see what the Z's look like. Zubite. There must be a zubite somewhere. Zubekite. Zunyite. What is that? Gold? Lead? I don't know what SV is. But basically you guys get the point. What we're dealing with here is much more complex than what geologists and astrophysicists want you to believe. Lithium, carbon, oxygen. This is just completely off the charts. No wonder they avoid trying to figure it out. They don't know how any of these minerals form to begin with, or why they're even in these combinations. But, you know, whatever. Today is May 7th, 2015. Have a good day, everybody.